Greetings, scientist. Today we're going to be looking at the paper that we have. You've been looking at copy paper, figuring out what the quantitative and qualitative descriptions of this paper is. So I'm just going to prove that my paper is the same as your paper, or very similar to your paper. I'm going to give you my actuals. So if we look at this, the length of our paper, we're going to say, let's look at this. It is at 8.5 inches. So let's record that my length is 8.5 inches. That's the abbreviation mark for inches, or I could say IN period is also what that looks like. My other measurement, starting at the bottom, working my way to the top. That one, we're at 11 inches. So let's look at here and let's label. This one is 11 IN period, abbreviation for inches. Now the next one we're going to look at is what is our the weight of our paper. And with that one, I'm going to do a little bit of folding because I've got my balance over here, and it's going to cause me to have a little bit of some issues with trying to get it to sit on there well. So I'm going to fold mine up. Let's pause for a minute. My balance is zeroed. We can see that one. Take my paper. I have folded it in half twice. Place it on this balance. Let's see what our weight is on this. This is 4.59 grams. 4.59 grams is my paper. Your paper is going to be close to that one. So I'm going to say 4.59 G. G for grams, okay? So here's what my measurements are. Yours are going to be very similar. So the change that I'm going to do is I'm going to burn my paper, but to burn my paper, I want to put it into this foil pan. So what we're going to do is we're going to put a foil pan on the balance, and you see what the weight of the pan is. But here's the thing, is I'm going to zero my balance. Shall we prove that the mass of the paper is still 4.59? So we're going to do this. Watch, it says it's a negative number. 4.59 is the pan. I've zeroed out the pan, so it's just the paper. So we're in the same spot. Yes, it's fluctuating a little bit because of the wind. We're going to burn this thing, and we're going to see what happens. Okay. So same paper. I'm going to crumble it up. You okay with that? I'm going to take it. Same paper. Set it down here. Now you're asking the question, why is Mr. Overholt burning this paper at home and not here in the classroom? Guess what? I'm not burning stuff in my house. I'm not burning stuff in the school. That wouldn't be safe. So I'm going to do it outside my house here. I'm going to burn my paper. I'm going to see what happens to it. What kind of changes are you seeing here? I'm seeing a change in color. Hopefully you're seeing that too. Do you think there's some heat being put off of this as it's going? Yeah, it probably is. Let's see. How hot do you think that fire is? Check out that temperature, ladies and gents. That's 969 degrees Fahrenheit. That's really hot. So yeah, we're burning. You don't want to touch that. It'll burn your hands. Fun fact. Where is all this going? Hopefully my winds don't blow away some of my particles, some of my matter. So far it's all still in the pan. I'm going to leave this be for a little bit, let it continue to go. Is it the same color? Is it the same material? What do you see? Do you see anything coming off of this? I see some stuff. I'm wondering if you see it on the camera too. So what do you notice? If you're making observations, you're recording them on your sheet or your science notebook. Could be interesting. I'm going to leave this be for a little bit, and then we'll come back in a couple minutes when it's cooled down a little bit, We're going to stick it back on that balance and figure out what the after weight is, after the interaction of flame and fire to our paper. Is there a new substance? Is this the same substance we had before? Let's talk about it. All right, remember that negative 14, that's the weight of our pan, so let's put this on there. So now what is the weight of just our paper, what's left over there? What's that called after you have a fire? What is that material that's there? What do we call that? Interesting. Our weight now inside of there is 0.9. I'm seeing it going from 0.91, 0.90. Let's go with 0.90. So 0 and 9/10 or 90 hundredths. Let's keep our decimal places the same. 0 and 9/10 of a gram. Was there a change in mass before and after? Notice I put a B for before and an A for after. After the fire, our paper now looks like this. Notice this too. Watch what happens when I stir it with my pencil. It's light. It's falling apart. It's kind of powdery. Look at that. So that's... Sorry about that. I was looking. So the texture of the paper has changed greatly. And so now we've got that. Can I measure the length? No, it's in a bunch of pieces. Can I measure the width? No, it's a bunch of pieces. It was a white solid. It's no longer white. It's gray. It's a little bit black there. A little bit of white in there. More gray than anything else. Mass, or the weight has changed. The size has changed. Is this a new substance? Is this still paper? The texture has changed. Talk about it. Figure out what you think it's going to be. Record it in your notebook. Record it in your answer sheet. And you and your teachers can talk about it. Thank you all. Remember, we do science well.
That's STEMtastic!